Lego in Tesco's right now. Just popped in and I found that I could buy these Lego sets. Small Lego sets for fairly cheap, and they look exciting, and wanted to go through and use them as the backdrop for the idea about how Lego can really help develop a number sense in young children, and probably at all ages, and exactly why that might be the case. So we'll start with the bottom one, the Batman. Okay. So the first thing to note about these is the Lego instructions book. The instruction book is a set of instructions done in an orderly fashion. Any set of instruction is also called an algorithm. It's a step-by-step thing to follow. By following these, where only one thing changes at any given time, you're going to get the sense of an algorithm and be able to break things down into smaller steps. One thing that students do way too much is try and do too many steps, like 7 all in one. And this creates a big problem because it's hard to think of all of these in your head, and therefore you make mistakes. The way to remedy that is to start going back to one change at a time. There's Batman. Sometimes there are certain operations that occur first, like with BIDMAS, you have to do brackets, indices. But then when we get to division and multiplication, they are paired. And if you have a ton of addition and subtraction right next to each other, then you don't need to specifically do any one first. They're all going to be the same thing. The same as this here. Could have put that on in any order, and we could call it commutative. Okay, starting with some of these. First things first, with these instructions, it creates a sense of spatial awareness. It also creates a sense of arrays, like grid system. So we have at the bottom a 3 by 3, which we could call a matrix. This is the idea of a matrix. We start to see matrices at A level. You also have a very important skill in maths here, which is classification, where we have to classify by different types of things, different colors. You've got the gray, we've got a 4 by 4, and even a different color. We have a 2 by 2, etc. It gives you the idea here of shapes that perhaps you couldn't quite describe, but you can feel them. And then you get this idea of spatial awareness by looking at all angles of the brick and seeing how it connects. If you want to see a collection of the current best Lego money can buy, click this video to see my top choices by age category. Now here comes a bit more of the problem solving. We have different colors to help differentiate here, but you can see there's some sort of angle there. So not only does it give you the sense of matrix arrays, but also of the different angles that we might be looking at. We can see that they angle, that they've got a connection of 2 along the top, and that must face in 90 degrees. So we get this idea of perspective drawing as well, like plans, because obviously it looks very different from here. It has less information. We can spin it around and see things. That's why if we have a lesson in class about perspective and drawing, it's much better to have Lego out, or at least something that we can build what we draw, connect blocks or whatever. It gives us a sense of number, a sense of size, spatial awareness, magnitude, etc. Again, we have a similar interest. We see that this brick is clear, sort of open, and this is darker. So we can assume, based on previous patterns, so pattern recognition, that this is going to be some sort of angle, because where there is an angled brick like this, the part that's angled seems to have the holes there. So we're using logical deduction and pattern finding as well. I'm also now thinking that based on where I put my finger down, even if I were to push another piece on top, if I did it in this corner, it's prone to falling over. And you see this has its own idea in physics, that you have a smaller base at the bottom, bigger on the top, and it becomes unstable. But the bigger base on the bottom with the small on top, it's all more stable. So you're getting a feeling for physics and mechanics. When people study mechanics at A level, the biggest problem they have is they don't understand how physics works. One of the things you can do in a mechanics lesson is demonstrate live some experiments, like pushing your finger across the table to experience resistance, and also balance puzzles like this, or manipulatives, to try and simulate the understanding of gravity and all of those things that you may have got and missed from playing with Lego, playing sport, out on the playground, centrifugal force on those roundabouts, Okay, let's continue. So now we've got a 2x1, and that has to fit onto here, 1 in, 2 across. So again, we're talking about coordinates here. So if our reference point is the back, we're going to go 1 down and 2 across, and that's where we should find it. And that forms the basis of Cartesian coordinates, right? The idea that you have a reference point and everything's relative to it also extends into things like position vectors and more advanced coordinate systems. If you look at these, in maths and gradients, we have the idea that we can measure how steep something is by how far it goes across and how high it goes up. So the diagonal element here would be the gradient. And you can see that this goes across 1 and goes up a standard amount. But you can definitely get some bricks that will go across 2 and up 1, giving you the idea of rise over run or gradient. And it gives you that intuition about something, that if you have a 2, so like a 1 across and 1 up, or a 1 across and 2 up, or a 2 across and 1 up, that these will provide different steepnesses or steepness for this diagonal part. You see this here. This is not very stable. So if this were to push down enough, it's not very stable on its own, because it's not being held by anything but those 2 at the bottom. And to get a better idea of engineering or stability, we could put this big old brick on top, and then suddenly that's being held not only by the brick underneath, but it's connected to this next to it. And so we have something much stronger. So we carry on with our algorithm. We've got certain things to do. We've got the algorithm to here, and then we've got a sub-algorithm that shall then be added. It's getting very exciting. Noticing also this phenomenon with the bricks, right? Look how they're not exactly in line. When I used to make a Lego build, I would always try and twist them around so that they were in line, because we don't have a stabilizing force in 2 directions. We only have it in 1 on the right. And that goes on there, has the ability to twist and rotate, right? I don't know if they intended for that to happen. It's less likely to happen here, because as we twist around this way, what's happening? This, which sticks out from the point of pivot, which is at the center of that brick there, that stick out circle, it's slightly away and therefore swings outwards. And this brick here is stopping it from doing that. So that's why we can get away with only 1 connector underneath there. If we had 2 connectors like here, there's no way that's moving left or right. It's a fantastic way to understand physics, isn't it? So it's become even more stable than before, with less plastic used, right? So we always want to save the environment. So we're also learning about optimizing resources. So we've got less plastic, because this would be sticking out, right? So I don't know if the original Lego makers intended for this, And if they did, I'm taking my hat off to them because that's very good. I can see here that we've got one of those 3x3s that go on the top. And I don't need to count 3x3 using those funny symbols that we use to represent numbers. Here, you see there's one symbol, there's another symbol. And early in life, when you go to school, teachers of primary school and nursery are obsessed with getting you to remember the symbols of the numbers. But unfortunately, just knowing these symbols, that doesn't tell you anything about mathematical ability. It doesn't tell you about quantity. So when you're learning numbers with quantities, physical objects that you can touch and count and hold, that's going to give you number sense, not the idea of writing symbols that represent quantities. And that's often where even highly numerate people go wrong, thinking that these abstract symbols could have been anything and therefore maths doesn't mean anything. Well, yeah, they could have been anything, but it doesn't detract from the fact that they represent a certain number of objects. And so these manipulables, the things that we hold, give us that number sense and allow us to fully appreciate all the crazy interplays and relationships in mathematics. And really, the appreciation is the beauty. Wow, would you look at this? That's shaping up to be a fine little building top, in my opinion. I think it's a building top. But it's more than that. It's a sense of accomplishment. Every little brick that gets put on here is a little win. And in that sense, we have a very positive environment that's fairly easy to do, one little bit at a time, that shows progression and the value of discipline, that eventually it will turn into something wonderful and to be proud of. And therein lies happiness. Small progress on a daily basis. Last thing, we are going to make this little thing, which is binoculars. I think they're binoculars, aren't they? Come on. They reuse them as binoculars, no doubt. We're facing this way. Orientation, again, we've got spatial awareness. I do note that these are grey, and in the picture they're supposed to be sort of a cream colour, but I'll let it slide. These Lego sets were so cheap that I can't be mad at them. It's great value for money, I'd say. And that's going on the end here, falling apart. There's another lesson in life. If your plans fall apart, stay calm. Put them back together again, slowly. And if necessary, start from the beginning. And that's all you can do. You'll find success that way. Okay, I think everything's looking good and aligned now. But these bricks, they are pretty good investments. If I save this brick, let's say it's worth 1 penny now, maybe a few years' time it could be worth 2 pennies. I've doubled my money. And that kind of investment teaches you that Lego could be good for investment. It teaches you about investment. If you buy something for £1, you get double your money later. That's 100% return on investment. That's a very good, it probably won't be as good as that, but it's just an example. And they probably will hold their value. Wow, 3 little bricks, 3 investment bricks. But I think this has been a great opportunity to see the skills involved in something even as simple as this, where we are using mathematics, or at least developing mathematics, and all of those skills that we'd like to see by the time you get to at least primary school, maybe secondary school, and even beyond at A level, have their very humble origins in early years, where you're playing with things like Lego. The diagram only gave him one of these chuckers, so we've got 4 spare bricks. And if you found it useful for parents that are trying to think of really useful games and experiences for their children, then please do share with them. Take a look at this. Even spins around on here. Awesome. Gotta love Lego. Thanks, everyone.